right, now for 75, what do they give us? They give us y equals 4x squared. And to figure out your a value or where your focus is or where the directrix is, we have to put it in that other format. And that other format says you were so conditioned to do y by itself. I mean, you're just conditioned to do that. I understand that. But we need to get it in this x squared equals 4ay forms. Basically, you want the x squared by itself. To do that, you would divide by 4. I'm just going to flip the order. So you get x squared equals y over 4, which we can think of as x squared equals 1/4 y. So what's the constant in front of the y is just 1/4. So that means 4a, okay, has to be equivalent to 1/4. And when you divide by 4, we get a as 1/16. So that's why it says, it's got to be 1/16 away from the vertex. That's where you get your a value there. Also, and I think it came up in 53. So in 53, when you did your work, when we did our work, we ended up with x plus 1 squared equals y minus 1. And so we're looking for what's the coefficient in front of the parentheses, because we're looking for something of this form: x minus h squared equals 4a times y minus k. Where you're like, well, I got the y minus k. Well, just think of that as a 1. So x plus 1 squared equals 1 times y minus 1, and that means 4a equals 1. A is 1/4. So just like I know it's different because you're so conditioned to say, hey, let's get y by itself so we can graph it. But when we're talking about directrix and focus, we want to get the quantity squared by itself, which changes things just a little bit. All right, anything else or any other questions we can go over and just kind of clear anything up. All right, hopefully the answer sheet helps a little bit. If you've missed any, I will collect that here in a little bit. All right, ellipses. All right, there's circles we did in another section. They're actually part of conic sections. We did circles, and then we did parabolas. We're going to talk about ellipses, and we're talking about hyperbolas. These all can be defined geometrically. When I say geometrically, a circle, you've learned all of the points, the set of all points that are the same distance from a fixed point. That's your radius. Parabola, we say, all right, you take a line and a point, and you find all the points that are the same distance from both. You guys need them?
Yeah.
All right, get notes. Ellipse. We can do something similar. Anybody else think got notes? You too? All of you. Oh, man, that was not very good. Now, ellipse, that's just an oval. Fancy term for an oval. Yep. Back there, we have a blue sheet if you would. I'll grab these. All right. Yeah. Still okay? Yep, you can keep. No, that's fine. Absolutely. Still looking? Very good. Okay. All right, let me see if I can explain this. Okay, here is the definition. We see it right there. An ellipse is the set of all points, x comma y, the sum of whose distance from two distinct fixed points. Well, a foci would be one distinct point. 2 distinct points plural would be, or a focus would be 1 point. Foci would be 2 points. Is a constant. All right, let's see here if I can explain a little bit. So you take any 2 points. They can be anywhere. And now, give me a number. Okay, give me any number between 20 and 30. Okay, give me a number. 22. 22, she says. All right, so 22 is the magic number. So we want to find, so you measure. So let's say I measure from here, this is 10, and then this is 12. Those add up to 22. Now find every other point that when I take those two lengths adds up to 22. So I find another point, okay, say here, and let's say this is 12, and this is 10. Wait, don't do that. And then this is 10. That adds up to 22. But when we're done with all of those points, it's going to form an oval. It's going to form an ellipse. Okay. So this one right here, this point right here, that might be 5. What would this have to be? 17. Okay. This might be 8. Then this distance would have to be 14. Okay. So that's how you do that. You get 2 points, then you just start measuring. And then when you're done, you get an ellipse. These 2 points, what are they called? Foci. Okay. You're called your foci. We're going to get what's called a major axis and a minor axis. The major axis will be the axis through the foci, which is the longer one. And then there's going to be a minor axis, okay, through the middle on the other side. And then where the center will be in the middle. Okay. So you see that the equations here, a couple key things we got to talk about. What is A? What is B? Okay, so if you got x minus h squared over a squared plus y minus k squared over b squared, the bigger number, okay, will tell you whether it's horizontal or vertical. Okay. So a is always bigger. So you notice here how a is now underneath the y. Horizontal ellipse is wider than it is tall. Okay, hamburger. Vertical ellipse is taller than it is wide. Hot dog. Okay, I guess how you refer to that. Okay, so A will always be the larger denominator. Okay, A is always along the major axis. This is major axis. B is along the minor axis. Okay, the total distance from here all the way across will be 2A. The total distance of the minor axis will be 2B. Once we know the A and B value, we basically just go that distance on each side to get our ellipse. C is always inside the ellipse. It can't be outside of it. It doesn't make any sense. Okay, C has to be always inside. And we'll have to figure out that C value here in a second. I'll show you how to do that. Okay. Now, the vertices. There's a tendency to think there's 4. I mean, that's kind of like your instinct, but there's really only 2 vertices. The vertices are on the major axis. They are in line with the foci. So the vertices and foci are on the major axis. I'm going to put that down here. The vertices and foci both lie on the major axis. Okay, so there's 2 vertices, 2 foci. If you want to talk about these points here, they're called the endpoints. The points on the B here, they're called the endpoints of the minor axis. Okay, that's just the way they're referred to. Okay. Now, this is just a kind of a little bit better picture of what I was talking about here. A little psychedelic graph paper, I call it. So, do you see where the foci are? Okay, they're on the inside. This one here and this one here. And all you're doing is you're taking, and we're drawing circles radiating out from both of those in both directions of unit 1. So you can specifically see here, if I take a look at this point here, and I connect it to the 2 foci, that length, you just count the circles, would be 1, 2, 3, 4. What would be this length here? It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what's the sum? Sum is 16. So what are all those sums going to be? They all got to be 16. So I pick another point on the ellipse. Okay, so I pick this point right here, and I connect to the two foci. It's going to be 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So you just keep doing that. You measure, plot those points, connect it. You'll have an ellipse. Here's one focus. Here's your other. Okay, always on the inside. The sum of the distances from the two fixed points, okay, will be related to the ellipse. It will always be 2a. Okay, it will always be 2a. Okay. So you pick any point on here. That point to here, d1 plus d2. d sub 1 plus d sub 2 has to equal 2a. Okay. Now, there is a relationship between a, b, and c. Okay. You already have it on your paper. What's it say? The relationship is for a, b, and c. Does it say c squared equals a squared minus b squared? All right, so that is a relationship. So c squared equals a squared minus b squared. All right, and you're going to say, well, that can't be true because a squared plus b squared has to equal c squared. But that's only for what? Right triangle. We're not talking about a right triangle. We're talking about ellipse. I at least want to go through why that is true. Okay. You know that d sub 1 plus d sub 2 equals 2a. We just went through that. All right, now I conveniently drew this so things will work out nice. But let's take a look at this figure here. Okay. These points, both this distance, d1 goes from this focus to b right there. d2 goes from this focus. This is going to be a right angle here. This length is c. This length is also c. And then this length will be b. I only need one b there. So what will d1 squared equal? That's a right triangle. Still Pythagorean theorem still holds. d1 squared has to equal b squared plus c squared. We agree on that? What's d sub 2 squared have to equal? It also has to equal b squared plus c squared. All right, now I'm going to come back to this. So I want to get d1 by itself. Take the square root of both sides. And over here, I'm going to take the square root of both sides. All right, now I'm just going to do it over here. We said that d sub 1 plus d sub 2 has to equal 2a. All right, replace d sub 1 with the square root of b squared plus c squared. Replace d sub 2 with the square root of b squared plus c squared. All right, what is square root of b squared plus c squared plus the square root of b squared plus c squared equal? They're both exactly the same thing, right? What do I get when I add those two together? Or can I add the two together? Yeah, you just make it 2 square root of b squared plus c squared equals 2a. I'm going to divide both of these by 2. And I get square root of b squared plus c squared equals a. Now I'm just wanting to show you where we get that relationship from. So now I'm going to square both sides. And so I get b squared plus c squared equals a squared. And that's close, but then the one at the top, I got c squared by itself. So I get a squared minus b squared. That will be very important. Okay, that's how we're going to figure out where the foci are. Okay, so c squared equals a squared minus b squared. All right, now before we get to that next one, all right, I want you to just take a look at that. See if you, what would the equation of that ellipse be? Look at what you got at the top. Look at what you got on the screen. What would the equation of this ellipse be? How do we figure that out? All right, just take a second and think about it. Which general form would you use from the top? Which general form? Aiden, is any of this sinking in yet? What's that? Okay, so you got those. Basically, you got four different ones where the center is not at 0, 0, and the center is 0. What's this general form? Just
The center is not at 0 and x comes first.
all right. So read it to me. Read it out loud.
X minus h squared divided by a squared plus y minus k squared divided by b squared equals 1.
Okay. Yes. So I'm going to start with that. X minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. That is the one that is horizontal because does the A have to be bigger than the B in this case? Yes, because it is wider than it is tall. What will, all right, the H is -2, the K is 3. So we can substitute that in. So that gives me X plus 2 squared over A squared plus Y minus 3 squared over B squared equals 1. All right, how do you figure out A and B? Camera. Look at the little picture there. Make sure you understand. So you got to have an idea. What does A represent? What does B represent? All right, so you got that picture at the top. You got the picture here. All right, McKenzie, you know how to figure out A and B yet?
No, but I know what they represent.
What do they represent?
A is the major axis, and then B is the minor axis.
Okay. Is A, now think real quick, is A the whole major axis?
No.
Nope, it just goes from the center to the end. So right there, that is your A. Okay. And this will be our B. Well, from the figure, what's that? Oh, just count boxes. A is what? 7. A is 7, and what's B? B is 3. So that is 7. This is 3. So all we got to do now is make that A squared. X plus 2 squared over 7 squared, which is 49, plus y minus 3 squared over 9 equals 1. Okay, so that equation corresponds to that ellipse. Okay, so if you see the 49, you take the square root of it, that's 7. So I go 7 to the right, 7 to the left. Square root of 9 is 3. I go 3 up, I go 3 down. I got the 7. Okay. I will talk about the foci in a second. Okay, there are 2 foci in there, but we'll worry about those in the next problem. All right, so this is the one you have. So it says find the center, find the 2 foci, find the 2 vertices, and then sketch its graph. I'm going to change the scale, just like we did a little bit yesterday. Make this 1, 2, 3, 4, and then same thing here, 1, 2, 3, and then -1, -2, -3, -4. Quit doing that. And same thing here, -1, -2, -3, and -4. Okay, just spread it out a little bit. All right, so in this case here, it doesn't have a number underneath there, but that's just a 1. So make that x squared over 1 plus y squared over 9 equals 1 for that. Where's the center at? Okay, if it's just an x squared, just a y squared, center's at 0, 0. Center 0, 0. Now, your a squared and our b squared. What's a squared equal? Okay, make sure we understand that from up above. Adam, what's a squared equal?
1.
No. A squared is always the bigger one. So a squared is
9.
9. Now, if you take a look, it should, oh, maybe it wasn't. Okay, I had it on here, but I might not have it typed on yours. If you go here, this statement right here, A is always greater than B, and therefore I should say A squared will always be the larger denominator. Has to be the case. That tells you whether it's wider or taller. Okay, so that tells you which direction we're going. So A is always greater than B for ellipses. Okay, so A squared will always be the larger denominator. Make that a squared. Okay, A squared will always be the larger denominator. Okay, so we got that. A squared equals 9, which means A equals 3. And B squared equals 1, which means B is 1. Take your square root. A is 3, B is 1. So I start at center 0, 0. To get this figure, okay, whatever's underneath the y, you can also think about it this way. That tells you to go up or down, just like rise and run. So you're going to go up 3 and put a dot. I'm going to go down 3, put a dot. Go to the right 1, go to the left 1. And now you actually have enough to graph it. Okay, so there's your ellipse. So you got a nice vertical ellipse. It goes up 3 to the right 1. Now, what are our center? We already listed our vertices. Those are on the major axis. And that will be 0, 3, and 0, negative 3. 0, 3, and 0, negative 3. All right, what's the only thing we're missing that it asks for? Okay. You can't tell where they're at this point. Okay, even though those are the 2 key points where we measure how far we add to. How do you find them? Well, what's that little equation we have? It says c squared equals what? A squared minus b squared. A squared is always the bigger one. So c squared equals 9 minus 1. C squared equals 8. C equals square root of 8. That does simplify to 2 radical 2, but you can leave it as radical 8. That's fine. All right, you're going to need a decimal because you're going to have to put it on the graph. About what is the square root of 8? Okay, just type it in your calculator and hit enter. Brandon has 2.8. So at 2.8, I'm going to put a little X or a little dot or something there to show that that's where the foci are. What are the coordinates of that? Well, all you got to do for this case, you're going up from 0. It would be 0 positive square root of 8 is fine. 0 negative square root of 8. So that would be your 2 foci. 2 vertices, 2 foci. What is that? What do the 2 values have to add up to? Like any point on here. If I pick a point on here and I draw, that's my D1. That's my D2. What does D1 plus D2 have to equal for this case here? See if we pick that up. What do they have to equal? Marissa? 6. Yes, 6. Because that is 2a and it is also whatever the major axis is. So D1 plus D2 has to equal 6. Now, more often than not, it's not always going to be nice whole numbers like 2 and 4 and 3 and 3, but it'll still add up to 6. Okay, for that. All right, flip it over. All right, we got this one. It's in nice form. All right, which one has to be the a squared? 25. 25 is the a squared. My center is going to be negative 3, 1. And my a squared is 25. My b squared is 4, which means a is positive 5, which means b is positive 2. What is all that noise out? Is that an internet? All right, so go ahead, graph what you know, put your center down. Negative 3, 1. Okay, now a is 5. It's underneath the x, so you're going to go left and right 5. B is 2. You're going to go up 2. You're going to go down 2 from that center. So you really got enough to graph it. You still need to find the foci, though. And we still need to list the actual points. Okay, well, that's a pretty good ellipse. Okay. All right, how do you find the foci? Hayden, what do you think?
We do c squared equals a squared minus b squared.
Okay, good. C squared equals a squared minus b squared, which is going to give me c squared equals 25 minus 4. And so that gives me c squared equals 21. C equals square root of 21. All right, that tells you how far to go from the center. Okay, how far to go from the center. Now we're going to have to go left and right because that's the major axis. Well, approximately what's the square root of 21? 4.58. 4.58. So I'm going to go 1, 2, 3, 4, and then 5/8. And now 1, 2, 3, 4, and 5/8. So for your foci, hold on here. When you're listing those points, you can keep it in terms of the exact value, the square root of 21. Don't give me a decimal. To get the x coordinate, you're just basically starting at negative 3, and you're adding square root of 21. And then the y value is going to be 1. So you can just write it like that, negative 3 plus square root of 21, comma 1. And then the second one would be negative 3 minus square root of 21, comma 1. Oh, I didn't mean to do that. List their vertices. We already listed the center, didn't we? Center is negative 3, 1. Our vertices are, what is that? 2, 1. I know it slid on me a little bit here. Vertices 2, 1, and what is that? Negative 8, 1. Stag on board. Negative 8, 1. Okay. All right, so we got everything there for that ellipse. All right, we're just going to do number 3. We're not going to get to that last one today. All right, what's the problem? Doesn't look anything like we want it to look, does it? Okay, so we got to make it look like that. So all of the ellipses we want to equal 1 as well. And you want to have a quantity squared. Well, anytime you want a quantity squared, you're going to have to complete the square. So here's what I'm going to tell you to do. Get your any term with an x together first. So let's make that 9x squared plus 36x. Get your y's together. Plus 4y squared minus 24y. Move the 36 over. They move the constant over and make it negative 36. Now we're going to have to complete the square. We need to get this 9 and 4 out of the way. We're going to factor those out. So we're going to factor out the 9. It gives me x squared plus 4x plus, and then we're going to put a blank in there. And factor out the 4 out of both of those. Okay, and now over here, I'm going to have negative 36 plus both of those. All right, now what goes in that first blank? You take half of 4, it's 2, square that, I get 4. Now don't forget it's being affected by this 9. 9 times 4 is 36, so you're going to add in a 36 over the other side. Same idea here, half of negative 6 is negative 3. Square it, you get 9. 4 times 9 is positive 36. So I have positive 36. So now I'm going to have 9 times the quantity x plus 2 squared plus 4 times the quantity y minus 3 squared equals, all right, I got a bunch of 36s over there, but the first one is negative. So when you're all done adding together, you're going to equal 36. All right, every time, though, what does an ellipse equal? What's on that right-hand side? Always equals 1. So how do I make this equal 1? What's that? Divide by, well, I should do the other way. Divide by the number on the right. Okay, divide by the 36. Divide by the 36, because now this is going to take care of the 9 and 4 when I do that. So that's going to give me x plus 2 squared, because what happens to 9 over 36? That actually just becomes a 4. Plus 4 divided by 36 is a 9, so I end up with a 9 here. Y minus 3 squared equals 1. So I end up with a 1. All right, you go ahead and finish it. Find the graph it. If you're not quite sure, just hold on. If you think you're good, find the center. Figure out your how far to go left and right, up and down. And then don't forget to find your foci. right, so a squared is the bigger number. A squared is 9. B squared, which means a is 3. Square root of that. B squared is 4. B is 2. So our center is -2, +3. So you go over -2, up 3, 1, 2, 3. Okay, you got a point there. How far left and right do we move? Okay. Katie, how far left and right do I move? 2, because whatever's underneath the x. Okay, so don't say it's not always what the a is, it's whatever's underneath the x, which would be the b in this case. We got 2 left, 2 right. I go 1, 2, 3 up, 3 down. So that gives me, okay, my general shape. Vertices. Okay, there's only 2 vertices. Carter, what are they? What do you think?
Is it -2 and 6?
-2 and 6 is one of them,
And then -2 and 0.
and -2 and 0. Oh. You should get combat pay, Holly, for having to sit through that.
What?
You should have to get combat pay for sitting through that.
She let us go in her room.
Oh,
so-
good. All right, C value. What did you get for the C value, Anna?
For the C value, I got square root of 5.
Square root of 5, because C squared equals A squared minus B squared, which is 9 minus 4. So we get C squared equals 5. C equals square root of 5. So yeah, you got to go square root of 5 from the center up. What is that, about 2.2? Is that about square root of 5? So 2.2. Marissa, how do I write those points for the foci?
It's -2 and then 3 plus or minus square root of 5.
Good. And if you want to do it in one shot, you can do 3 plus or minus square root of 5. Yep, that's fine. If you want to do it separately, absolutely. I think I got them over here. Holly.
I think yesterday's too.
That would be yesterday.
Oh, it is?
If it says 10-2 on. Yep, so you're good. Okay, we'll finish that other one tomorrow, but there is a few problems here.